So, this system here, you put up for maybe NEPA, you put down for inverter. This system and this system, they are exactly the same thing. They do the same work. The only difference is that with this one, you have to manually operate it by yourself. And this one thinks for you and then just does the operations for you. That's the only difference between these two things. So you already know how to use this one, but let me show you how this one works. So how this one works is very simple. I've explained it in my previous video, but let me just try to explain it again. So how this one works is very simple. We have 3 inputs on this system and we have 2 outputs on this system. The first input here is for inverter. The second input here is for generator. The third input here is for the grid. That's national grid power. Then we have 2 outputs here. For this particular video, I'm going to use this particular one to represent the first output, which is primary load. Your bulbs, your fan, your socket, your television, your fridge, freezer, normal stuff that you normally want to run all the time with your inverter. Then this one here is representing the secondary load. This is maybe your air conditioning, your water heater, your electric cooker. This is stuff that you mostly want to use only when you are using maybe grid power or generator power. I made this changeover with 2 separate outputs so that when you are using your inverter, you are going to use only your light load. So that way you are not going to run your battery down. And then if the grid comes, you can use your heavy load. Now somebody might be like, but I'm already using this kind of changeover in my house and it's already doing the job for me. Fine. There is a difference. The difference is that when NEPA takes light, you have to maybe go and check your changeover. You have to check maybe your maybe your air conditioner, your water heater. You switch them off before you come and change over. This one, you don't have to necessarily switch off anything or switch off anything. It just disconnects those power sources because they are connected separately. And then even if you are like, okay, maybe I can still use a changeover to achieve that. In this video, I'm going to explain to you why there is still a difference. Now, let's put this system on. The first thing that is going to come on immediately you put the system on is the solar because it doesn't have any waiting light. This light indicates inverter, this light indicates generator, and this light indicates grid. Then these 2 white lights here indicate waiting. So once you see this light on, it means that there is power source for that stuff, but just that it has not changed yet. I reduced the power timing delay for this particular video so that it's going to be fast, so you'll be able to get the point straight. So now, if the box is powered on, the first thing that comes on is the solar, and it powers just the primary load. But once you see this white light, it means grid is available. Once grid enters inside this house, you see that grid can power both the primary load that the inverter was powering before, and also the secondary load that only the grid or the generator can power. I don't know if that part makes sense. So if the grid goes, it's going to change back to the inverter, but without the secondary load. I don't know if you understand it. So let me disconnect the grid. So now that the grid is out, you see, it changed back to the inverter with just the primary load. So if you were running your air conditioner as at the time when the NEPA went out, you will notice that immediately the grid just go off. It's going to automatically change back to inverter. But without that heavy load, maybe you were cooking with your electric cooker, or maybe you are using pressing iron, those things will not be dumped on your solar. Do you get the concept now? So now, I have a feature here whereby let's assume that maybe you want to do something with your heavy load temporarily. Let's say, for example, you just want to pump water, or maybe you want to just blend something, or maybe you want to do something that normally you did not connect to your primary load. I introduced bypass buttons here. So the function of this bypass button is to make the inverter that is supposed to carry only the primary load carry the secondary load for you at that time. So you push this button and you make the inverter carry the secondary load. And when you are done doing what you are supposed to do, you push this button to disengage it for it to carry just the primary load. So let's assume that while you put this button on to carry the secondary load, while you were now carrying that secondary load, the grid now came on. So while the grid came on, you were still carrying that secondary load. Maybe you did not even know that the grid has even come on. And then the grid now came in and took over those loads that the solar was carrying before. You forgot about it. You now went to start adding more things on and all those kind of things on. Remember, maybe your solar could only handle maybe your pumping machine that you just wanted to use and pump water small. But now that NEPA have bring light, you now can start on your air conditioning, on your water heater and all those kind of things. You forgot that your bypass is still on. I introduce a feature here that makes it that once the grid goes, it doesn't come back to inverter with the high load that it was carrying before. It's going to come back to inverter with just the low load so that you are going to know that, oh, the grid has now gone. Then if you still now want to carry that said high load, you are going to manually come and turn on the bypass again. So when the grid goes now, you see that it came back to the inverter, but without the high load that it was carrying on the grid. If you want to carry that high load back, you have to manually trigger that bypass to get it to come on. So the function of the grid and the generator function almost the same way, because if the generator comes in while your solar is powering on, it powers both the secondary loads too and takes over from your inverter. And when you put off your generator, let's say for example you wanted to pump water, you now on your generator, maybe your solar cannot carry your high loads at all, so you don't engage the bypass. So you now on your generator to pump your water and whatever you are done, it will change. And then once you're done, you just turn off your generator and then it's automatically going to come back to inverter. So let's say you were just in your house, you were chilling one day, there is light, the grid came, took over, everything is functioning properly. Then maybe something now happened in the house, maybe a particular socket is faulty or something, you want to work on it, or maybe this, that, or maybe an emergency, anything, and you want to shut off this entire system so that power is not going to be supplied to the house. That is the reason why this guy is here. All you need to do is just to push it down and everything is cut off. When you are done with the emergency, you turn it to the right and everything comes back functioning. Then there is something I also introduced in this system, because a lot of people were asking me, what if I'm off grid? This system can function off grid and on grid. This system can function like me now in my house. I don't use my grid to charge my inverter because it's going to be very expensive for me on my unit. So I invested more in solar panels to make sure that my solar panels are the only things charging my battery. But let's assume that maybe you want to use your grid or your generator to charge your solar. I added a extra outlet here that powers just is the one that is going to go to inverter. It's separate. So if maybe you want to charge your inverter battery with the grid, when the grid is available, that guy is going to be available. If the generator is available, that guy is also going to be available. Now somebody might be like, okay, so what if grid and generator is not available, but then I turn on my bypass? Will it also charge my solar? No, it's not also going to charge your solar because I did not connect it that way. That's basically like feeding the same source where it's getting power from. I don't know if you understand it. So it's not connected that way. So I have another feature here aside from the bypass button here. Now, let's assume that you are using a socket that is designated for primary load. Let's say, for example, in your distribution box, you've already separated your load, primary load, secondary load. And then maybe in your room, your socket was designated for a primary load, maybe your television, your fan. And then you went there to plug maybe something like maybe a rice cooker or maybe something that is not supposed to be on the primary load. You went there to plug it because the grid was on. Maybe you just want to use it temporarily, or maybe you want to use it to iron your clothes and you plug that your iron on a primary load outlet. Now, what do you do? Now, the grid is on. If the grid goes, it's supposed to come back to solar. But now you are plugging that high load on a socket that is not designated for high load. And you don't want that load to come back and destroy your inverter because it's not supposed to be there. What do? I added the feature here. All you need to do is just to turn this guy to the option written no solar. What it means is that the system is going to remain functional. But the moment the grid goes, it's not going to switch to the solar. Everything is just going to go blank. What that means is that your this thing is now going to give you an opportunity to switch off that particular load, unplug it from that outlet, and then return this guy back to the normal position. So let's see that happen. So the grid goes, you see that everything goes back up, and then you can now put your solar back on after unplugging that stuff, and then you are going to get power normal. Then let's also now have another scenario. So let's say you are using the grid and you are using your solar, but then you are this kind of person that maybe you have a lot of solar, so you don't really want to be using your grid all the time, because if the grid comes, it may be taking units from you when you already have solar. So what is the point in that? I also have a feature for you. There is also this part here that is written no grid. All you need to do is just to turn it to the right. What that means is that it disconnects grid, that no matter how light comes in the day, grid will never engage. The only thing that is going to engage is your solar, or if you turn on your generator, but grid will never engage. So what that means is that you are going to be using your solar anyhow you like until you now optionally want to turn on the grid. Then you put it back to the normal position, and it's going to allow grid to be able to enter the house. There is a button on this side, but I don't know how I'm supposed to, because I don't want to like disturb this whole thing. But there's a button on this side here. This button is specifically for people that use generators with maybe remote start or maybe contact start. It's not for people that use manual generator. Now you can use a manual generator with this system, but you just need to keep the setting at manual. But for people that use generators that have remote start, there are two functions for you here. The switch is on this side here. The first function is what we call backup mode. What that backup mode means is that when generator and when grid is not available, the system checks for solar. If solar is not also available, it automatically tells your generator to come on. That is the backup mode, so that you are not going to be completely out of light in the house. So if grid is not available and inverter is not available, turn on generator. Then the second option is what we call aggressive backup mode. What that means is if grid is not available and the thing changes to inverter, even though inverter is available, still turn on the generator for me. Maybe for example, you want to use a certain high load that will only work either on the grid or the generator. So once your grid goes out, it will automatically supply the high loads like your lights and everything with the inverter. But it's now going to automatically send a signal to turn on the generator so that you can continue using the high load you were using before. So I feel like with this, I've covered most of this. You have a volt meter here. You have an amp meter here. Some people were asking me, it would have been better for me to add a watt meter. I was not able to find a watt meter for this configuration, and I wanted something that if I do, like my design is going to be consistent. If you see my other videos, you notice all my designs are consistent. So, for you to know watt, all you need to do is just to multiply voltage and amperage. If you bring out your calculator and you see 220 volts times 2 amps, what you are going to get is the wattage. Do you understand? So that's basically what this system is about. So I feel like with this, I've explained basically what it is.